problem, this integration, the method we would use would be substitution. We'd allow u to equal 3x, and of course du would be 3dx. And since we don't have 3dx, we'd multiply through by 1/3 to get dx by itself, suggesting now that we can write this problem in a new form, 1/3 du in place of dx, and not the cosine of 3x, but the cosine of u. The integral of cosine is sine, so we have 1/3 sine u plus c as our answer. But if we want our answer in x, we need to back substitute. We need to write in place of u 3x. 3x needs to go in place of the u, so it seems to me that c is our answer to number 1. Number 2, a couple methods suggest themselves, Hopital being one of them, but probably not the most efficient. The most efficient would be to spot the fact that there is an x cubed that can be factored out of the numerator and denominator. So if I take an x cubed out of the numerator, what's left behind is a 2x cubed plus 6. And if I go to the denominator and factor out an x cubed, I'll have left behind a 4x squared plus 3. Now obviously the x cubes will cancel, and I'll now have the limit as x goes to 0 of 2x cubed plus 6 over 4x squared plus 3. Although originally we couldn't just do direct substitution, now we can. And of course these two terms, the first in the numerator and the first in the denominator, will go to 0 and we'll be left with 6/3. So 2 is our answer here. D is our choice. In this problem, the first rule in the piecewise function leaves off at 2. If we put 2 in and square it and subtract 3 times 2, and if we add 9, we find that 4 minus 6 plus 9 equals 7. That's where the second one needs to pick up. In other words, if 2 could go into the second one, 2k plus 1, it would have to equal 7, where the first one left off. That means that 2k would have to equal 6, or k would be 3. So we're asked to find the value of k here, and the value of k would be 3. In this next problem, we're asked to find the derivative, and we should recall that the function can, perhaps should be written as the cosine of 4x. The whole cosine is cubed, and so it presents us a better look for finding the derivative, which would start out with 3 times the cosine of 4x quantity squared, then times the derivative of the inside, and the derivative of cosine is negative sine of, in this case, 4x. And then once more, we have to multiply by the derivative of 4x, which would be 4. So to pull everything together, the derivative here, f prime x, would be negative 12 cosine squared of 4x times the sine of 4x. So our choice here is limited to B. B is our answer. Our final problem in this set is about a function that's a cubic, and it has this orientation. That is to say, it points positive. The first value, left to right, will be a max, and then we'll have a minimum as the second value, as again, we're looking from left to right. The minimum will be the second one. Well, this max and this min, the derivative at those points is equal to 0. I hope you were finding the derivative here, 6x squared minus 6x minus 12. We want to know when and where that equals 0. If we pull out a 6, we have left behind x squared minus x minus 2. And if we factor the quantity in the parentheses, we have x minus 2 times x plus 1. And that suggests solutions at 2 and at negative 1. This one here must correspond to where x equals negative 1. It's the one to the left. And the one on the right, it must correspond to where x equals 2. And therefore, we're looking at C as our answer.